Now we will just try to solve some problem. So we have next two session for the problem solving. So this class and after then one more session. So we will try to, so in these two sessions, we will solve the problem just up to basic level. And then we will also advance the level of problem into a further class. Okay. So what is the whole idea? The whole idea is very simple. What we have to do? We have to write the kinetic energy matrix. And this kinetic energy matrix is half Tij eta I dot eta j dot. And we have to go for potential energy matrix. And the matrix element is half Vij eta I eta j. And what we have to do? We have to solve the secular equation. And when we are going to solve the secular equation, V minus omega squared T, the determinant of this must be equal to 0. And obviously, if we have n number of degree of freedom, then there is n cross n matrix for T as well as V. And once we will solve this secular equation, so this is our secular equation, then we can find the normal frequency and normal mode. So this is the whole idea, and in the examination you will see that they will ask you to find the normal mode, normal frequency, and all this stuff from this. Okay, so let's straightforward go for first problem. So first problem is a triatomic molecule. This is very fundamental problem, and from this problem we will just try to implement each and everything of the theory whatever we have learned into the last class. And then I will just discuss how to do the calculation in a very fast manner or in a shortcut manner, such that in the examination you can do this, you can use this mathematical acumen. And basically I will just try to use the symmetry of a problem to solve the complete solution. And let's see how we can approach. Okay, so let's go for our triatomic molecule. And this is linear triatomic molecule. We will also solve the circular triatomic molecule. And but first question I will solve with the first principle. Each and everything I will calculate it such that you can again go for your theory and you can match each and everything into that particular theory. So I am taking the very simple triatomic molecule. The mass is m. There are three masses. Those are attached to two springs of the same spring constant k, and the mass of a particle is m. And you can just elongate it. This can vibrate something like this. So there are n type of motions can be possible, but we have to try to understand the three independent motion, which is very popularly known as normal modes. So once we know the three independent motion, we can make a linear combination of this. And after then, what we can do, we can just write the complete solution. So let's try to go for this. So obviously, we have to choose origin. So I am just choosing this as my origin. And what will be degree of freedom for this particular system if it is just moving along x-axis? Can anybody tell me what is the degree of freedom? क्या होगा degree of freedom? This is not fair. What is degree of freedom?
4, sir.
4. My goodness. I have to go into history, isn't it? कैसे होगा 4? बताओ. आप लोग रिवीजन नहीं करते। हम बताओ क्या होगा, क्योंकि जब तक डिग्री ऑफ फ्रीडम नहीं निकालोगे आगे काम कैसे करेंगे? एनीवन? What is
So
degree of freedom?
moving along x-axis only.
Yes, they are moving along x-axis only.
1 degree of freedom.
1 degree of freedom. Wow. How many number of particle is there?
3 degree of
3.
freedom.
3 degree of freedom. Very good. So if you will keep this particle free, that is x1, y1, z1. If you will keep this particle free, x2, y2, z2. If you will keep this particle free, x3, y3, z3. Okay. And if we have these all particle free, then what we are going to do? We have 9 degree of freedom, but it is just moving along x-axis. So y1 is equal to 0, z1 is equal to 0. Similarly, y2 is equal to 0, z2 is equal to 0. Similarly, y3 is equal to 0, z3 is equal to 0. So only generalized coordinate is x1, y1 and z1. So this is my x1. And this is, and I can, so there are 3 degree of freedom. So that means we have to solve 3 cross 3 matrix. So what we have to do, I can assume when the system is in equilibrium, there is not any disturbance, then I can assume this coordinate is x10 for first particle, x20 for second particle, and x30 for third particle. Okay, so these are equilibrium points. So you remember in the last class, what will be my qi naught? That is replaced by x10, x20, and x30. Are you people comfortable? Okay. Now what we have to do? We have to just disturb the system from our equilibrium point. So what we will do? We will just try to pull it up. So when we are trying to pull it up, now what will happen? And you have to think naturally. Just think naturally. Don't think that this particle will go into this direction, this particle will go into this direction. It will be very complicated. Here we are just solving the linear 3 particle chain. You can have n number of particle in the chain also. Then it is very difficult. What will happen to another particle? So you have to just go for the simplistic disturbance. So what is the simplistic disturbance? I can assume this particle will go into this direction, this particle will go into this direction, this particle will also go into this direction. So I can say my first particle is here, second particle is here, and third particle is here. And this is my x1, this is my x2, and this is my x3. Now, we have to first write the potential energy, because writing the potential energy is really main challenge. But sometime you will see the writing the kinetic energy is also very a big challenge. Okay. Anyway, so what is potential energy? So potential energy will be stored into this spring and this spring. So how much energy will stored into this particular spring? Half k into change in length square. Isn't it? ये तो आप सबको क्लियर है ना?
Yes, sir.
वेरी गुड. सो चलो यहां पर देखते हैं क्या हो रहा है. फर्स्ट स्प्रिंग की बात कर रहा हूं. हाफ k into change in length square. So what is change in length square? Present length minus original length. So what is present length?
x2 minus x1.
Very good. x2 minus x1. What is original length?
x20 minus x1.
Very good. x20 minus x10. Very good. So now this is my stored energy in a first spring. Now just tell me what will be our stored energy in the second spring?
x3 minus x2.
Very good. x3 minus x2
minus x30 minus
x30 minus x20
square.
total ka whole square. Very nice. Okay. चलो नाउ अब आपको याद है हम लोगों ने ईटा का यूज किया था, कुछ याद है? व्हाट इज ईटा?
Q
क्यू आई जीरो, क्यू आई माइनस क्यू आई जीरो, ऐसा किया था ना, एंड दैट इज योर ईटा आई। चलो अब हम ईटा को इंक्लूड करेंगे, हाफ के, नाउ लुक एट हियर, x2 को इसके साथ ले जाओ, 2 को 2 के साथ, सो यू कैन राइट x2 माइनस x2 जीरो, हाँ या ना? अरे कुछ तो बोलो।
Yes, sir.
x1 माइनस x1 जीरो, मुझे बच्चों की आवाज बहुत अच्छी लगती है, ठीक है? सो दिस इज व्हाट, x1 माइनस x1 जीरो, हाँ या ना? हाँ, बताओ यहां पर क्या होगा?
x3 minus x3 0.
वेरी गुड, x3 माइनस x3 जीरो, गुड, माइनस
x2 minus x2 0.
very good, x2 minus x2 0 whole square. Now can I write half k, इसको क्या
Eta.
लिखेंगे बताओ?
Eta 2.
वेरी गुड, ईटा 2 माइनस ईटा 1 होल स्क्वायर, कितना कॉम्पैक्ट हो गया है ना? सो व्हाई वी आर डूइंग द कोऑर्डिनेट ट्रांसफॉर्मेशन, यू पीपल रिमेंबर दिस थिंग? लास्ट क्लास में मैंने पूछा था ना कोऑर्डिनेट ट्रांसफॉर्मेशन क्यों करते हैं? डॉक्टर श्यान आप हैं क्लास में?
यस सर।
लास्ट क्लास में पूछा था, सिंपल हो गया चीजें,
हाँ सर।
है ना? और ये देखो गायब हो गया ना, इक्विलिब्रियम पॉइंट कहां आ गया? 0 0 पर आ गया, है कि नहीं?
यस सर।
गुड, चलो हाफ के x3 माइनस x, सॉरी ईटा 2 माइनस ईटा, सॉरी ईटा 3 माइनस ईटा 2 होल स्क्वायर। चलो जी, आप सेटिस्फाइड हो? नाउ अब मैं आपको यहीं पर शॉर्टकट के लिए भी बता देता हूं, शॉर्टकट में कैसे लिखोगे, एग्जाम में इतना करने की जरूरत नहीं है, ओके? एग्जाम में हमें फटाफट कैलकुलेशन करना है। नाउ लुक एट हियर, हाउ यू विल गो फॉर दिस, यहां तक क्लियर है ना? कुछ पूछना है किसी को? चलो गुड, अब देखो हमने क्या किया है, लुक एट दिस एरो, आई हैव जस्ट टेकन द वेरी सिंपलिस्टिक अप्रोच ऑफ डिस्टर्बेंस, इक्विलिब्रियम पॉइंट से मैंने बहुत ही सिंपलिस्टिक डिस्टर्बेंस किया है। नाउ लुक एट हियर, if you are watching this particular spring, the second particle is going to elongate the spring or compress the spring?
Elongate.
Elongate, very good. The first particle is going to compress the spring or elongate it?
Compress.
Compress. So the change in length will be elongate minus compress?
Yes, sir.
Yes?
Yes, sir.
So that is eta 2 minus eta 1 डायरेक्टली लिख दोगे। चलो इस स्प्रिंग की बात करते हैं, बताओ तो यहां पर क्या होगा? थर्ड वन elongate और compress?
Elongate, sir.
elongate. Second one
Compress.
compress, eta 3 minus eta 2. तो आप एग्जाम में डायरेक्ट ऐसे लिख दोगे, लिख लोगे ना?
Yes, sir.
वेरी गुड। नाउ वी हैव टू राइट द पोटेंशियल एनर्जी मैट्रिक्स। सो मैं फिर से दोनों तरीके से बताऊंगा, शॉर्टकट भी बताऊंगा और आपको कैलकुलेट करके भी बताऊंगा। यहां तक क्लियर है? किसी को कुछ पूछना है? बिकॉज आई एम गोइंग टू रिमूव ऑल दिस थिंग, ओके? एक प्रॉब्लम अच्छे से कर लो, सारे प्रॉब्लम हो जाएंगे, डोंट वरी, ये मेरा चैलेंज है। चलो नाउ ओपन इट केयरफुली, इसको आप ओपन करो। सो हाफ के ईटा 1 स्क्वायर 2 टाइम ईटा 2 स्क्वायर प्लस ईटा 3 स्क्वायर माइनस 2 टाइम ईटा 1 ईटा 2 माइनस 2 टाइम ईटा 2, सॉरी ईटा 2 ईटा 3। एवरीवन इज कंफर्टेबल? इसको ओपन करेंगे तो यही मिलेगा हमें, है ना? नाउ व्हाट विल बी योर V11? That will be del square V upon del eta 1 del eta 1. यही तो लिखते हो, याद है मैट्रिक्स का जो फॉर्मुलेशन था, टेंसर के फॉर्म में लिखा था ना, समेशन देकर, डबल समेशन देकर के, याद है? चलिए बताइए क्या आएगा, व्हाट विल बी दिस टर्म? जस्ट टेल मी. K, you have to differentiate eta 1 square twice, है ना? And everyone will be 0, so that is K. Similarly, 1 2, what you will get from 1 2? That value is del
Minus
square V upon del eta 1 del eta 2. That value is what? Minus K. What will be V13? 0. Isn't it? 0. So similarly, you can calculate all the term, but I will tell you how you will find it in a shortcut manner. Okay? This thing you can do it in a clerical way. You can बहुत आराम से कर सकते हो. Now, let us go for the physics. Physics is very beautiful. This potential energy matrix is basically a symmetric matrix. So if it is symmetric matrix, then this one is a diagonal or off diagonal?
Diagonal, sir.
Diagonal. This one is diagonal. This one is diagonal. But this one is off diagonal. But for a physicist, we can rewrite this term as a half K eta 1 square 2 times eta 2 square eta 3 square. Hence, I know my potential energy matrix is a symmetric matrix, because interaction between 1 and 2 and 2 and 1 is the same thing. So it is a symmetric matrix. So if it is symmetric matrix, I have to write the thing in a different way. We are not a mathematics student. We just want to see the symmetry in our expression. So when we want to see the symmetry in our expression, what I can write? I can write this thing as eta 1, eta 2 minus eta 2, eta 1. Are you getting my point?
Yes, sir.
जरा
No,
इसको
sir.
नो न्यूमेरिकल वैल्यू इसकी ये दोनों को ऐड करेंगे तो यही आएगा ना.
Yes, sir.
यस, लेकिन ये तो नंबर की वैल्यू है. आप जब मैट्रिक्स के फॉर्म में देखोगे तो आपके पास कौन कौन सा टर्म होना चाहिए? 1 2 का भी टर्म होना चाहिए, 2 1 का भी टर्म होना चाहिए. आर यू गेटिंग माई पॉइंट?
Yes, sir.
So
Yes.
if you are seeing the whole matrix, then you have 2 1 term as well as 1 2 term.
Yes, sir.
Okay, and this is not 1 2. You can write it 2 1 also, na?
Yes, sir.
But this is not the thing. The both have their contribution into this. So you can symmetrize this particular expression. So I just bifurcate this thing into this form. Can I write this thing into this form?
Yes, sir.
Yes.
Yes, I can write, because I am just trying to visualize the matrix. मैं मैट्रिक्स को विजुलाइज करने की कोशिश कर रहा हूं. I am not doing only merely calculation. Are you getting my point? Now, just tell me what will happen to this cross term.
Eta 3, eta 2,
Minus.
Eta 2, eta 3 minus.
eta 3, eta 2.
Exactly. Very good. Now look at your definition. Some people is asking why we are doing this sort of calculation, this sort of derivation in our class. Now look at here. Unless until you will not understand the derivation, it is very difficult to enhance your concept. Okay. Now look at very carefully. So the role of this particular expression is gone. Look at very carefully. What is my V matrix? Half Vij eta I eta j. And what is Vij? Can anybody define what is Vij?
Matrix element it is.
Matrix element. Which matrix element?
I cross
I cross j ने I and jth matrix element. I cross क्या होता है?
IJ.
Ij matrix element. Very good. So now look at my word very carefully. Can I say Vij is the coefficient of half eta I eta j? Correct me if I am wrong. Can I say Vij is the coefficient of half eta I eta j? Half is very important. Now write the V matrix. The first element is 1 1. So you have to take the coefficient of half eta 1 eta 1. What will be coefficient? बताओ.
K.
A. यहाँ पर eta 1 square नहीं है. This is eta 1. Are you getting my point?
Yes, sir.
Yes, you are a student of physics, so try to see the symmetry. Are you getting my point?
Yes.
Very good. So, वाह, कोई बहुत अच्छी जगह पढ़ाई कर रहा है ना? Very nice sound. Very good. The second will be coefficient of what?
Minus K.
Huh? Coefficient of what?
Minus K.
Minus 2K.
Eta 1, eta 2.
Eta 1, eta 2.
eta
So
2.
here you will take half eta 1, eta 2. That is what? Minus K.
Yes, sir.
Very good. Wow. किसके पास से इतनी अच्छी आवाज आ रही है? हाँ? Obviously, some people.
Zero.
Next one, eta 1, eta 3. Eta 1, eta 3. ये कर लिया, ये कर लिया. That will be 0. There is not any coefficient. Now, 2 1. बताइए क्या होगा?
Minus
So you will go for this one, okay? This represent this one. See the matrix. So this will be minus K. Wow. 2 2.
K.
फिर से ध्यान देकर.
2K.
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 Very good. That is 2K. Here is 2 is there. Half eta 2 eta 2. That is 2K. Now 2 3.
K.
Two.
Minus K.
Minus K.
Minus K.
Very good. Now 3 1.
Zero.
0. 3 2.
Zero.
Minus K. 3 3.
3 3.
K.
K.
K. So this is your potential energy matrix. अब एग्जाम में बहुत फास्ट कर लोगे, लेकिन ये हमेशा ध्यान में रखना होगा. You have to symmetrize the thing. Okay. And now you have to just go for the coefficient of half eta I eta j. लिख लो, हिंदी इंग्लिश बांग्ला मलयालम जिसमें भी लिखना है वो लिख लो. आप ये लिखोगे कि half eta I eta j, the Vij is a coefficient of half eta I eta j. Are you people happy? So this is my V matrix. Now we will go for what? T matrix. अब हम लोग किस में जाएंगे? We will go for T matrix. Okay. Now, what will be your kinetic energy? The kinetic energy is half m x1 dot square plus half m x2 dot square plus half m x3 dot square, and you can have x1 minus x10 is equal to eta 1, x2 minus x20 is eta 2, x3 minus x30 is eta 3, and you will, when you will take the dot, then x1 dot is equal to eta 1 dot, x2 dot is equal to eta 2 dot. So you have to just go for the kinetic energy matrix is half m eta 1 dot plus half m eta 2 dot plus half m eta 3 dot. Now, what is your kinetic energy matrix? Half Tij eta I dot eta j dot. तो क्या मैं कह सकता हूं what is Tij? What is Tij? Coefficient of half eta I dot eta j dot. Okay, so this is coefficient of half eta I dot eta j dot. So now here that is, you are very lucky that you have only diagonal term. So kinetic energy matrix, what will be 1 1 T11?
M.
M. What is T12?
0.
0.
What is T13?
0.
0. Now you are enough smart, but don't worry, it is not necessary that always you will get kinetic energy as your diagonal term. It is not necessary.
This will also be symmetric, like potential.
हाँ जी, अगर वहां पर वैसा आ जाए तो वहां पर उस तरह करना होगा. eta 1 eta 2 डॉट होता तो उसको हम बाइफरकेट करते. ठीक है,
Yes, sir.
हमेशा. Kinetic energy matrix is also symmetric. Potential energy matrix is also symmetric. Clear है ये? चलो. So now next step पर क्या करना होगा बताओ?
Normal.
Using
Normal
the secular equation.
Secular equation. So you have to write what? Secular equation. So when you will write the secular equation, then you have V minus omega square T, that must be equal to 0. And from here, I can write K minus omega square M minus K 0 minus K minus, sorry, 2K minus omega square M minus K 0 minus K minus omega square M, that must be 0. Clear है ये? So now we have to solve this determinant. Please determinant solve करते समय थोड़ा अपने +2 के रिवीजन को जाकर के जरूर कीजिएगा. We will use some property, है ना? So what is my first property? So this is what? Column, है ना? So I am just going for C1 is equal to C1 plus C2 plus C3. So when you will add all this thing into C1, you will get minus omega square M minus K 0 minus omega square M minus K minus omega square M minus K and K minus omega square M. Sorry, this is 2K minus omega square M. That must be equal to 0. Clear है यहाँ तक? And next is what? R2 में ऑपरेशन कर रहे हैं, R2 minus R1, and R3 में भी ऑपरेशन कर रहे हैं, R3 minus R1. So what will happen? Minus omega square M minus K 0. This value is 0. This value is minus 3K minus omega square M minus K. This is 0. Minus, so this will be 0. And you have K minus omega square M. That must be equal to 0. ये सब आता है ना? नहीं आता है तो NCERT जाइए और उसके अपने डिटरमिनेंट में NCERT क्लास 11th या 12th जहां भी है, 11th में होगा आई थिंक, वहां से आप जाकर इसे ठीक कीजिए. ठीक है? So now we can expand it about this point. So what do you have? बताइए. कुछ गड़बड़ है क्या?
The
Sorry.
second element,
But
yes.
2 हाँ ये. So that will be 3K. Okay. So this will be 3K minus omega square M, and you have K minus omega square M. That must be equal to 0. So what is value of omega? Omega is equal to 0. Omega is equal to root under K upon M. Omega is equal to root under 3K upon M. So this is, now what is your fundamental frequency? What is your fundamental frequency? These three are what? Normal frequency. ये तीनों को क्या कहोगे? Normal frequency. So what is your fundamental frequency? Omega is equal to 0 or omega is equal to root k upon m?
Root k upon m.
Very good. So omega is equal to root k upon m because normal frequency must be non-zero positive value. So that value is root k upon m. And this will be my fundamental frequency. And what about this one? This is first overtone. So two normal frequencies are there. Omega is equal to 0. We'll have also tell you about some different type of motion. Let's see which type of motion is there. Now let's go for finding the normal modes. Yahan tak clear hai? So we will just write it omega 1, omega 2, omega 3. Okay. So let's try to go for first one. Okay. So what is my equation? K minus omega square m minus k 0 minus k 2k minus omega square m minus k 0 minus k minus omega square m. So this is my equation. Okay. So let us assume omega is equal to 0. I have one column vector that is A1, A2, A3, which will satisfy the equation. And what is that equation? V minus, and this is omega 1 squared T x1 is equal to 0. And then we have to find the value of A1, A2, A3 from this particular condition. Okay. So when you will put omega is equal to 0, then what will be equation? जरा बताइए तो मुझे फटाफट. बताओ क्या होगा? K minus K 0 minus K 2K minus K. Very good. 0
minus
K K. Very good. Okay. Now, so here A1, A2, A3, that must be equal to 0. And from there, you can solve the equation. A1 minus A2 must be equal to 0. Second equation is minus A1 plus 2A2 minus A3 is equal to 0. Third is minus A2 plus A3 is equal to 0. ठीक लिख रहा हूं ना? So from there, I can have A1 is equal to A2 is equal to A3. Yes, सही है? A2 की वैल्यू A1, A2 की वैल्यू A3, है ना? So A2 is equal to A3 is equal to A1. So we have this, and this will satisfy this equation also. So yes, this is our value. So what is my x1? I can write my x1 as A1, A1, A1. And now we have to find the suitable value of x1, sorry, A1. How you will get the suitable value of A1? कैसे मिलेगा?
x1 transpose.
Very good. x1 transpose, kinetic energy matrix, x1 must be equal to 1. So what is x1 transpose? And I assume this is real number. We are not doing quantum mechanics. A1, A1, A1. And what is this kinetic energy? M 0, 0, 0, M 0, 0, 0, M. You have A1, A1, A1 must be equal to 1. Yes? Everyone is comfortable? So we have to solve this equation. So when you will solve this one, then A1 is equal to 1 upon root 3m. So role of mass will come in here. So first is omega is equal to 0. What we have? We have x1 as 1 by root 3m. That value is 1, 1, 1. So this is your normal modes. First normal modes. कुछ पूछना है तो पूछो, फिर हम लोग सेकंड के लिए बात करेंगे. सारे चले गए क्या? चलो, एवरीवन इज कंफर्टेबल? यहां तक क्लियर है ना?
Yes, sir.
चलो, लेट्स गो फॉर सेकेंड वन. सो व्हाट इज योर ओमेगा 1? ओमेगा 2 क्या था? k अपॉन m. लेट्स से x2 इज इक्वल टू b1 b2 b3. चलो, k अपॉन m पुट करो तो क्या मिलेगा यहां पर? रूट अंडर k अपॉन m. व्हाट विल बी दिस मैट्रिक्स? 0 माइनस k 0 माइनस k k minus k 0 minus k 0, and you have b1 b2 b3 must be equal to 0. You are actually solving v minus omega 2 square t x2 is equal to 0. क्लियर है ये चीजें?
सर नाउ ओमेगा 2 स्क्वायर टी टर्म वो वाली नहीं मैट्रिक्स लेंगे साथ में, v माइनस ओमेगा स्क्वायर टी.
अरे वो तो लेकर के यहाँ पर लेकर के तो रखा हुआ है.
यस सॉरी. ओके सर. ओके,
इसी में तो पुट कर रहे हैं, इसलिए तो इसको अलग से रखा हुआ है. तुम देख नहीं रहे हो, मैं उसे मिटा नहीं रहा हूं.
यस सर.
क्लियर है?
यस.
गुड. चलो, तो अब बताइए यहां से क्या होगा? b1 इज इक्वल टू 0 माइनस b1 plus b2 minus b3 is equal to 0, and b1 is equal to again 0. So from here b1 must be equal to 0 and b2 must be equal to b3. ठीक है ना?
Sir, last equation minus b2 is equal to.
एक ही बात है यार, क्या है ये? ठीक है, माइनस b1. ओके, चलो, क्लियर है ये? सो b2 is equal to, sorry, b2 is equal to 0 and b1 is equal to what? Minus b3. Yes, sorry, b1 is equal to minus b3. So x2 is equal to what? So your x2 is equal to b1 0 minus b1. And now we can find the value of b1. How you will find the value of b1? x2 transpose kinetic energy matrix x2 must be equal to 1. So you have b1 0 minus b1. Your kinetic energy matrix is m0 0 0 m0 0 0 m, and you have b1 0 minus b1 is equal to 1.
Sir,
सर
here B2 equal to 0 na, sir?
Yes,
Last
b2 is equal to 0.
सर देन फिर b1.
Okay, sorry, b2 is equal to 0. Sorry.
फर्स्ट में b1 है, थर्ड में
Oh, b2 is equal to 0. Extremely sorry. Minus b2 is equal to 0. Okay.
Upper one B1 equal to 0.
No, b2 is equal to 0. Now multiply this thing with this, na? 0 into b1 minus k into b2, 0 into b3. So b2 is equal to 0. Extremely sorry. मेरे दिमाग में वो चल रहा था, लिख में कुछ और दिया हूं. ठीक है? Please correct it. That will be b2 is equal to 0. Okay?
Yes, sir.
Okay. So now from here, you can calculate b1 is equal to 1 upon root 2m. So second equation is all about omega is equal to root under k upon m, and x2 is basically 1 upon root 2m, 1, 0, minus 1. We will discuss what is all this story. ठीक है? Okay, let's go for next one, third one.
Sir, wait a moment, sir.
Sorry.
Wait a moment. Okay, sir. Thank you, sir.
Okay. चले आगे. So let's go for what? Third one. So, and don't worry, in the examination they will ask any one thing, but we have to learn all this thing, है ना? हमें सारा चीज समझना होगा. So, what is omega 3? बताइए omega 3 क्या है?
Root 3k by m.
Very good. Root 3k by m, and let's say x3 is equal to c1, c2, c3. Okay. So now put it. Omega is equal to root 3k by m. क्या मिलेगा आपको? We are just putting v minus omega 3 square t is equal to 0. Okay. And we are putting x3 is equal to 0. चलिए बताइए तो क्या मिलेगा? First term is minus 2k. Second term is minus k. 0. Minus k. Minus k. Minus k. 0. Minus k. That value is minus 2k. And here we have C1, C2, C3. And that value is equal to 0. So now, what will be next one?
Minus 2c1.
Very good. Minus 2c1 minus c2 is equal to 0. Minus c1 minus c2 minus c3 is equal to 0. Minus c2 minus c3 is equal to 0. Sorry, 2c3 is equal to 0. So from here, I can say c1 is equal to c3 from these two equations, isn't it? And what about c2? c2 is equal to minus 2 times c1 from this equation. Clear again? And now when you will put it here, you have x3 as your c1 minus c2, sorry, minus c1, c1. And now you can find the normalization condition x3 transpose t, x3 must be equal to 1. I am writing it directly. C3 is 1 upon root 6m. You can directly 1 square, 2 square plus 1, that is 6 root 6m. Okay. Now, so we have solved completely, but what is physics behind that? Let's go for the story of this particular physics. Okay. यहाँ तक clear है everyone? देख लो. Okay. Let's try to go for this one. So what we have actually 3 particle, and let me clean my board first. We have actually 3 particle. The first particle is m, second and third. When omega is equal to 0, if first particle is moving 1 unit, then second is also moving in same direction with same condition and same one. So this is one type of translation motion. So what you can assume? You can assume this is my first particle, I am second one, and this is my third one, and everything is moving like this. Are you getting my point? Either this or this. Yes? So this is all about omega is equal to 0. What about omega is equal to root k upon m? So this is one independent motion.
Sir, can you repeat the omega equal to 0? I can't understand, sir.
When this particle is moving 1 unit, this is also moving 1 unit towards right. This is also moving 1 unit towards right.
Yes, sir.
What is the meaning of that?
Me.
Meaning of that, they are just moving just as a rigid body, isn't it?
Yes, sir.
Something like this. Okay, assume I am second one, my head is second one, this is first one, this is third one. So if it is moving in this direction, then everything is moving in this direction. So this is one independent motion. Are you getting my point?
Yes, sir.
Okay. Now second one. So what is second one? So this is 1, 0, minus 1. So if it is moving 1 unit, it will remain rest, and it is just moving in opposite direction.
Yes, sir.
So what will happen? For this particular omega, this is another independent motion. So I am second particle, so I am rest, and these two particles will move like this. Are you getting my point?
Yes, sir.
Yes. And what about third one? The third one, root under 3k upon m. If this particle is moving 1 unit, the third one is also moving 1 unit, but second one is moving in opposite direction with the double of the magnitude of first and 3. You remember what is your x3? Your x3 is 1 upon root 6m, 1 minus 2, 1. So what is this? So something like this, isn't it? These two will move there, and this will move in opposite direction. These two will move, these two hand will move in same direction, but second one will move in opposite direction, something like this. If you are doing the break dance, you can do it very nicely, but I am not able to do this thing. So this is your complete independent motion. This is all about the normal modes. This motion is represented by this normal mode. This motion is represented by this normal mode, and this motion is represented by this normal mode. And what is my complete solution? The complete solution is, everyone is comfortable right now? Okay. So what is my complete solution? The complete solution is very interesting. And what we have basically eta 1, eta 2, eta 3 is actually C1, 1 by root 3m 111 e to the power I 0t plus C2, 1 by root 2m 10 minus 1 e to the power minus I root k upon mt, or plus I. If I am taking plus or minus, you can take it. And next, plus C3, 1 upon root 3m 1 minus 2 1 e to the power I root under 3k upon m into t. So this is your complete solution, and the value of C1, C2, and C3 you can easily find with the initial condition. And if you have initial condition, at least you have to find the initial condition for position, and you have to find the initial condition for velocity, and then you can find the value of C1, C2, and C3. And these all combination will give you some sine form, cos form, combination of sine and cos, and all this different type of oscillatory motion. And so this is all about the complete analysis of 3 triatomic molecule in one dimension picture. Everyone is comfortable? Yes? Are you people comfortable?
Yes, sir.
Okay. So please do practice of this particular problem, Hannah? Okay, so I will just take a very small break. Only I will just clean my board and then we will go for some more problems. So we have still half an hour, so we will use it very nicely. Okay.